So we're very excited that today is the first in a set of 2 primers focused on the All of Us program and associated resources. Our speaker today is Ruchi Munshi. She actually joined the Broad over a decade ago. After she got her bachelor's in biochemistry, she then started working as a research associate in the Broad clinical labs. While she was there, she fell in love with the intersection of biology and software. And so she transitioned as a software engineering role in the data sciences platform. She then again fell in love with trying to build software that could have a wide impact, and so now works as a software product manager for Terra. Her current role is in software product management at the data sciences platform, focused on the All of Us research workbench and supporting the development of the Terra platform. So these are all just exceptional resources to the community, both here at Broad and more broadly. So we appreciate you joining us today to teach us more. Thanks. And she's very glad to take questions during the talk. So if you're joining online, just go ahead and raise your hand or type in the Q&A and we'll voice it. Or if you're in the room, please come up to the mic to ask. Perfect. Thanks.
Good morning, everybody. Awesome. So I'll give you a little heads up that some of my talk today, we'll do a little bit of slides, and so give an overview of what the All of Us or AOU, sometimes I'll do a lot of shorthand in the slides. Yeah? Is it on? Oh.
It's for sure off now.
Oh, it's definitely not on.
There we go.
Great. Okay. So today we'll do a mixture of sort of overview slides of what the All of Us or the AOU program actually is. I'll use a lot of shorthand. And then what I would say like more than 50% of the talk today is actually gonna be a live demo. So I'll just walk you through the Workbench, which is the researcher environment for doing analysis and discovering all the data that's sort of like curated by the program itself. Yeah, so we'll first start with the overview so I can give you like big picture context, and then we'll zoom in on the demo of the actual Workbench platform. And you can interrupt me at any time, so like that will be fantastic. So here's a really quick overview. So the mission of the program is to go and recruit 1 million participants that effectively reflect diversity of the US population, to just better understand, longitudinally study them over time to understand like the health outcomes that they're experiencing. And so that's sort of like big picture what the program is doing. And there's an arm in the All of Us program called the DRC, the Data and Research Center. And that specific group is really, their goal is to acquire, organize, and provide all the resources in a secure environment that a researcher would need to make use of all that data. And so the All of Us Researcher Workbench is something that's sort of owned and sort of maintained by the DRC, the Data and Research Center, which is like a subgroup inside of the program. I think the All of Us program is actually like hundreds of people working on it. So the DRC is like one portion of that. The Workbench is one portion of that. I think as of today, they're like close to 50% through their goal of recruitment. Higher, higher. Every time I say a number of like how they're hitting their targets, it's always wrong and stale. So greater than 50% recruited. Okay, and I'm lucky to say that I'm one of them. So separate of working on the actual Workbench and the software development that goes into it, like over a year ago, I took maternity leave, and immediately after I gave birth, a really wonderful human being walked into the room and said, "Would you like to join the All of Us research program as a participant?" And I said, "No, because now is the wrong time for me to think about this. Come back in 24 hours and we'll have a chat. And then you can explain to me what your expectations are of me." But anyways, so she came back 24 hours later, we chatted. It was actually a very, very short process to join the program as a participant itself. I think the whole thing end to end was like 15 or 30 minutes, if I'm remembering correctly. So they take a couple of physical measurements of you as an individual right at the start of the program. So they have like a little bit of a baseline. All that information becomes available as a data resource downstream, completely de-identified. So like, but we'll talk about that in a second, is like what data is actually collected, because there's a lot more detail there. So it's interesting to both be contributing data and like, but also being aware of what's coming in like a year or two. And so it's an interesting perspective to sit on both sides of the program as a participant and also sort of guiding some of the development on the Workbench side. Okay, great. So let's go back to the data resource and let's talk briefly about what's actually there. So there's different types of access. There's 3 tiers of access one can have of the All of Us data. So then there's like the public tier access. This contains like, this is all de-identified data and sort of aggregated together. So there's some level of granularity that you have. This is a, I don't know if people have seen the public browser, but actually, I think I have a link in the next slide to it. Yeah, so here's like a live view of the data browser, totally public, you don't need to log in, do nothing. And you should be able to search for, for example, if you're interested in studying, if you're interested in building out a cohort that takes specific prescription medications or something, you can actually just type in the medication and see if there's any matches that come up. So I can see that, yeah, there are some participants that have claimed that they've taken this drug. So I can go in and say, hey, I'm loosely looking to find individuals or data on individuals with characteristics X, Y, and Z. And this is actually the right first place to start to see if the thing you're interested in learning is even present. And this is like the lowest barrier to entry. Question?
The boxes and the search box.
Why are these numbers, you're saying, different from, damn it. Different from which other numbers? These? I think this is like saying there's a denominator here. So like there's a total of 409K participants, and of that, 239 sort of match.
From the 21. Oh, I see.
You're asking what the 21 is. Sorry, is that what you mean? Yes, that's great question. Let's zoom in on that because it's not quite that way. So it's actually this 239,740 number is the number of participants who have been prescribed sertraline. And then there's 21 medical concepts. Now we're talking about sort of OMOP terminology that relate to a keyword like sertraline. So one could dig in a little bit further to look at what does that mean. And I think these are I think concepts is sort of a loose term here, but like, there's a concept of sertraline 50 mg. So there's a lot of concepts is like a uniquely OMOP thing, and we'll talk about that in a little bit. Yes.
What kind of data does the participant give?
Yeah. So right at the beginning, the measurements they're taking are like blood pressure, height, weight. I think those are the 3 things I remember distinctly. They also take a saliva swab. So that's the thing that will go through sort of genomics processing. And then the other sort of thing that they intake right at the start of the study is there's a survey that you fill out. And the surveys are actually like a series, those are things, the surveys continue longitudinally into the study. So, a survey probably comes out once every 6 months or something. And they'll sort of remind you to prompt you to take it. They've also started doing interesting things around games. So they've started putting sort of like brain activity games, and that's a way to that's one of the studies that they're conducting called Exploring the Mind. So then they'll be collecting that data and sort of curating it to share with researchers once they have enough mass. Awesome. So the browser is like a great first step. I totally recommend, even if you have no intention of using it, come and drop in some terms here so you can get a sense for what's in this data set. And then, so that's public tier. Then there's the registered tier data. So this is where you have to actually create an account and tell the program who you are and what institute you're affiliated with. So all of that kind of matters. But I think you get pretty instantaneous access for registered tier data. Here you get access to pretty much everything except for the super sensitive data types. That would include sort of like the sequencing data. So if you're in the registered tier, if you apply for registered tier access, you don't get access to the genomics data. I think you also don't get there. And then there's certain kind of identifiers that are stripped away, like zip codes and stuff like that, that could be considered PII. So you get access to pretty much everything but genomics, and then one level below is the control, and then one level deeper is the control tier data, which is everything plus genomics, essentially. Okay. In terms of how you actually get access, I think a lot of people get stuck at this part of it, which is why I've kept a slide on this. So a big thing is really, there can be some delay, I think, in the pieces around, if your institute isn't already, your institute needs to have an agreement with the All of Us program for you to like sort of plug into the network. Like, I would assume almost everybody in this room is gonna be your institutes will already be on the list. So I think you're probably good to go, but I think that can be a hurdle to cross. Then you create an account, that's pretty easy. Verifying your identity using login.gov, that can have some sticky pieces, but all these things, the support team is really great at resolving. So I think my advice to you is like, please email the support team if you get lost on any of these steps and you're interested, because they're really fast at getting back to you. And then there is like a training that you have to complete. So that's sort of, I think, like the longest task in this list of things is step 5 is complete all the research training that you have to do. And then that's basically it. Then you sign a code of conduct. Okay, so I sort of think of all the data types, they fall into like 4 organizational bins for my head, and that's how I think about it. So there's like the electronic health record data, which is structured in an OMOP format. And we'll actually look at that together in the live demo so you can get a sense of what that means. That includes things like diagnosed conditions about the individual, prescription drugs that they're taking, what are medical procedures that they've had done in the past, things like that. Then there's survey data about the participants. So there's some mandatory surveys that all participants take, so you'll get some basic information like self-reported ancestry and stuff like that. Then there's optional surveys. So then for specific participants, we'll look at some of the optional surveys. There's like lifestyle surveys. There were certain COVID-19 experience surveys, and they just kind of keep rolling in as different life events happen, and the surveys are sort of those things influence what surveys go out. Then there's like genomics data, so there's arrays data and whole genomes data. We'll look at that in a more zoomed in perspective in a second. There's also some long reads data and structural variants derived from the long reads data. Yeah.
And structural variants derived from the short.
Oh, great, and structural variants from the short read whole genome sequencing as well. Lee works very closely on all things, all of us, and Research Workbench, so whatever I can't answer, he's here to answer, basically. Okay. Then there's also the physical measurements that they do right when you sign up. We talked about that already. And then there's wearable data. So actually, if you wanted to opt in, you can sign up to get a Fitbit, and they're basically measuring your activity level, and that's another sort of data point about you as a participant that they're trying to round out. Okay. All right, so here's a deep dive into the curated genomics data, just because that felt pretty relevant for this room, and we can talk about this in more or less detail based on your interest. So in terms of short read whole genome sequencing, we have 245,000 samples, and I guess over 1 billion variant sites. To me, that feels like a big number, but I feel like this crew's probably used to dealing with that scale. And then there's also long read whole genome sequencing data. So there's a little over 1,000 long read samples. I think that number is increasing in a year or so. And then structural variants also derived from both long, short read data. And then I think this graph, which Lee created, kind of gives you a big picture of sort of scale across these different data types. So the largest swath we have is the arrays at 312K, and then 245 is the SNP indel, sort of whole genomes, short read, and then short read SVs, about 11,000 of them, and then long read whole genomes, about 1,000 of them. And then at the top right, there's sort of like, oh, some of these things have been joint called, and so if you're looking for deeper information about what data has been transformed into what kind of analyses, and also what file formats are available, we can dig into that. But I'm choosing not to voice out every single piece of information and rather just let you ask me. The other interesting thing to note is that there's also sort of subsetted data sets that are available. So there's like the full massive call sets that include all the participants ever. Then these are sort of smaller territories of subsetted data sets that we think are going to be interesting to people. So these have been created specifically to make it easier to get started, essentially, because there are smaller versions of the large data set. So there's one data set which is just taking into account sort of the common variants. Another smaller territory data set, which is taking into account all the exon regions, and a third one that's just a subset based on if something has a ClinVar variant reported, then like it shows up in that sort of subset. So they're sort of different experiments to kind of make it easy for someone to get started. That's essentially the gist of these. And maybe you're only interested in the exonic regions, so that will be the only thing that's relevant to you. And then there's different file formats for release. There's VCFs, Plink, BGen, HAIL, the different HAIL types as well. PGen is coming in 2024. Okay, fantastic. Any questions on this? I'm just curious, would you actually be, like, if you were trying to use these data sets, would you prefer to use the large call sets? Would you be interested in starting with some of the smaller call sets? Because I think this is really interesting for us to understand, like, what is the right way for someone to introduce themselves to a data set and want to get started with it? I'm going to take the silence as not sure yet.
For the ClinVar set, is it all ClinVar interpretations, like pathogenic,
Exactly,
US?
all ClinVar interpretations.
Because that seems like a lovely place to get some sense of kind of what's known and unknown, right?
Yes.
And what's been adjudicated, because people use that all the time for kind of gold standard comparison. So that, I think that subset seems
The third one,
useful.
yeah. I don't know which of these three is the most commonly used. Would you know by any chance? Oh,
The reason I say that is people who are doing kind of like association tests, and want kind of like common variants, they're gonna use that, and that takes into account population structure. Sorry, I'm kind of shoehorning that last sentence in there because we get that a lot at the help desk, like, how can this work? It's, gonna drop everyone from Middle Eastern ancestry. And no, it won't. So that seems to be the one we hear about the most.
Okay.
But I wouldn't be surprised if people are using exome and ClinVar.
Awesome. Oh, yes, Lynn.
Would be looking at the variant to see whether it's present in the data set, because we do a lot of variance analysis. Would it be possible to, or if I had the right access, to look up clinical information on a particular individual with a variant?
So you want clinical information on the individuals with that variant?
Yes.
This data would have, yes, because you can find out which individuals have a particular variant.
Yeah.
And if you're signed up in the control tier, you have to have the control tier access to do this. And then from there, you would have access to whatever EHR, we have from them.
Okay. So okay, so I would get direct access to their EHR.
Yes.
Okay. That's
Yes.
a lot of information.
Let's see if we can actually demo that in the Workbench so we can try that use case. Okay, so before we actually look at the Workbench UI, I just want to explain some functional components and give a little bit of a descriptor before we look at them together. So I'll probably start off my demo by talking about something called a cohort builder. It's essentially a GUI for defining a set of participants that you're gonna look at downstream for your analysis. So it's really a way to just take the 245,000 individuals worth of data and curating it based on characteristics you care about. So if you're Lynn, maybe you're gonna say, well, I only want the participants who have very specific variants. So, or maybe you're someone else and you're saying, well, I'm interested in looking at, I don't know, people who've been diagnosed with major depressive disorder. So depending on what you're trying to do, you could ask different questions and then curate that cohort. That's the point of the cohort builder. And the next step of all of that is, once you know the participants you want to look at, the next question is, well, what information about them? So again, in that use case we were talking about earlier, for these individuals, I want EHR data. Or for these individuals, I want to look at EHR plus survey data. Or maybe actually, you know what, for these individuals, I just want to start with genomics data to start with, and then I'll decide if I want to do more. So that's what the dataset builder is. It helps you define what attributes about those participants that you'll actually be able to extract. And then the workspaces are essentially an environment where you take that cohort, that data set, and connect it to the tools that are present in the Workbench. Okay, so now I think this is a good time to transition over Excellent, so you see it and I'm logged in. And so these are sort of the different workspaces that I've worked on in the last few months. So they just kind of pop up as sort of my most recently accessed items. And below are sort of my most recently used like notebooks or data sets. So this is just kind of a collection of like resources that I've engaged with. I'm gonna plug into a workspace that I like to use for demoing, and we'll sort of build out a cohort together. Maybe we'll do multiple cohorts because I think there's different use cases that are worth covering here. Okay, so I'm gonna create a scenario for us that I think is sort of a good one to work through because I think it's fairly representative of what a lot of different, I feel like especially if you're sort of an epidemiologist, this is the type of cohort that you end up building. So let's say I'm interested in studying participants who've had a diagnosis of major depression, who also who've been prescribed the drug sertraline, because it kind of gives me a sense for severity of what these individuals have, and it kind of normalizes that a little bit. And I'm kind of interested in I'm interested in finding individuals who've been prescribed the drug within 30 days of that diagnosis. So there's a time factor here that will really matter. And maybe what I additionally want is some of that survey data, especially the COVID-19 survey data, to understand the impact of COVID for these individuals. And maybe there's an age factor here. I really want to study people who are 30 and above, so I'm looking at sort of like working individuals and whatnot. Okay, totally fabricated. This is of my own imagination. Okay, so let's start. So the first place I would go to is drugs, and I'm going to put in the information on sertraline first. Okay, so there are different sort of brands, and earlier when we did the data browser, there were different dosages as separate concepts. I care about the larger abstract concept of someone who's been prescribed, so I'm going to go in. If I was interested in breaking this down further, what I could do is view hierarchy as a way to sort of dig deeper. So I can say, maybe I actually want a collection of different drugs, or kind of zoom out or zoom in on some of the details here. So, oh. Why did it complain? Yes, I did mean to click return to list. Okay, finish review. Every time you add criteria to your cohort, you essentially have to save each criteria one by one. And that's sort of like a very intentional part of the process here. So now it's going to add this specific criteria. I'm going to save it, and that's going to be step one in the definition of my cohort. I get to see that there's about 25,000 individuals, essentially, who match the criteria of taking sertraline. Now, because there's a time factor here, right? I want people who've been prescribed sertraline within a few days of a diagnosis of major depressive disorder. So that's where I've clicked this temporal flag. That's how I sort of indicate the time. Yes.
So I think that's a wider search
Here when we did it, because I think this is kind of just checking everywhere. It's not necessarily saying people who are necessarily prescribed it, and if it's information about the same individual in multiple places, I think it's like, this is a very loose search. So I would not take this as, I think this is, and I think this could pick up a lot of false positives. So this is, take it with that grain of salt. Great, but great catch, because the two, in a perfect world, the two would be exactly the same. Okay, and so now I'm gonna add the criteria around diagnosis. Okay, so I'm looking for people who have a specific condition. Okay, so there's even if we're thinking about something like depression, there's a lot of nuanced diagnosis that matter here. So depending on what you're trying to do, maybe you will want to use something very specific. But in my case, I'm once again using sort of like that abstract concept of depression or depressive disorders. And depending on how wide, and this gives you a sense of item count, so you know that if you're looking for a certain scale of data, you can kind of zoom out, zoom in based on that. So now I've gone from 25,000 to, oh, it hates me. Yes, question.
The counts, those are excluding the drug, so.
No,
Oh yes, the counts that we just saw just for major depressive disorder was excluding the drug. But here at this screen, what it's trying to do is marry the pieces together. Correct. Does that make sense? Okay. But I did something wrong because it's very upset. Oh, yes, I know what I did wrong. Okay, you know what? I messed up the logic, so instead of trying to fix it, it's just gonna be easier for me to. Okay, because I clicked the temporal flag, I have to indicate a time factor first. So I want a criteria that's X or more days after. So I think I'll be okay if someone was taking the drug sertraline within 30 days of that diagnosis. It's counting. Oh, so I think it's generating the graphs. I think the other thing that I know is we've trimmed from 25,000 to about 11,000 right now. Yeah. This is also going to pull up on the screen on the right-hand side is pulling up a lot more information. So now I'm able to look at things like, well, how do these 11,000 participants distribute by race or race and age? So it was collecting a little more data. But so now I have a sense for, okay, and so I loosely know that so far my criteria gives me 11,000 people. If I wanted to trim it further by age, I could do that pretty easily. So let me just show you, but I'm going to choose not to save the modifiers just because I think I don't want to trim this down any further. So age would be part of the demographics. And this is one of those things where it's like you're not expected to know where everything is. So it should be matching for you. I don't know what I'm doing wrong. I guess I should just write it. Yeah. So now I'm going to take my cohort. Okay, I didn't lose a lot. So there's a total of 375,000 individuals that are part of that age criteria, but once you map all the ands and the ors together in the query, it trims down. So now I'm going to go ahead and just create the cohort. So now I'm going to create the data set. So now I'm going to extract the pieces that are interesting to me. I have multiple cohorts in this. So what I'm going to do is select the one that I've just created. I can now select the concept sets that are interesting to me. So this is where I define what I'm going to extract out of all this. So if I was truly interested in just the whole genome sequencing data, that's essentially a checkbox that I can use. This is not the only way you can subset the genomics data, but in some sense, this is the easiest way I think you can subset the genomics data. So, and then whatever else I wanted to extract, I was kind of interested in the COVID-19 survey, so I'm going to go ahead and extract that. You can kind of go wide. I think the demographics are always helpful, so I kind of lead into that. I'm less interested in the Fitbit data. I could actually show you some of that if you're interested in it. So let's say you wanted to understand what was here for the Fitbit data. You could just simply preview it. That doesn't mean you have to extract it. So essentially what this is now doing is that it's creating sort of like a visual summary of what I've plugged into so far and what that actual raw data will look like from like a cherry-picked set of 10 participants that are de-identified. Okay, so there's no VC, oh. There were no VCFs for those individuals. I'm gonna do an easy version first. So here's like sort of 10 cherry-picked individuals from the list of 10,000 that we have. So this gives you a sense for what is the literal information that's going to show up in a data frame downstream that you'll have access to. And then sort of as you build on this, you can preview more or less as you want and get a sense for what's there. And whatever you select here is kind of what gets extracted for you downstream. I'll show you what some of the genomics extracted data will look like in a second. So just because I'm hitting the end of my time, I'm going to go ahead and save this data set. Okay, so by default, it kind of, essentially what's going to happen is that your cohort is going to get extracted from the database, from the curated database where it's living in, and it's going to be put into a pandas data frame for you to access, and it's going to drop you into a notebook. So it will just give you a link to sort of the data frame object that you can start using downstream. I think I might show you an example. My workspace is preloaded with some of the featured content that the Workbench creates, so I'll show you some of that. If you did want to see how all of these cohorts are defined, they're pretty intense queries, so it's the kind of thing that I feel like I wouldn't worry about, but if you're sort of interested in deep modification of the queries and being very specific in terms of what you're trying to extract, I know very few individuals who prefer the model of taking this query and modifying it for themselves, so have at it. Now it's just grabbing all this information, putting it into sort of like a Jupyter notebook. I've preloaded a cloud environment here right before the demo is started. It can take up to 5 to 10 minutes for the environment to warm up, which is why I've sort of preset it, but that's sort of like the time frame you should expect the first time you're spinning up these environments. Okay, I intentionally chose to bring us into this data fundamentals notebook specifically because I just want to highlight that the Workbench team, the support team and the education team builds out a lot of curated materials that you can just pick up as soon as you get in, either with register or control tier access. There's a featured page with tutorials that you can just like bring into your workspace, drag and drop essentially, and those will just make it very easy for you to learn how to like acclimate to the Workbench. That's essentially it. And yeah, I feel like you're all familiar with this interface, so I'm not going to dig deep into it. I think the big things I want to call out in terms of what's configurable here, so you can sort of scale up the CPUs and so on and so forth. There's a limit that you should be aware of. If you're in the free tier, there's a limit to how much CPU you can, how big your machine can be essentially. So there's restrictions there, but once you start putting in your own billing information from your own institution, then those limits, those ceilings go away essentially. You can also do, if you're using something like Hail, then you'll want a data proc cluster instead of a standard VM. So you'll be able to sort of switch between those two modes. You can also sort of do different kinds of storage disk options. They basically let you define like they basically are different cost options for where your data is kept. And those cost options differentiate because they change some of the latency on how quickly you can access that data. And there's a couple of different things to call out. So here, you're able to use Jupyter Notebooks. Very soon, we're building out, we're gonna roll out RStudio support. So you'll also be able to sort of see the RStudio interface plugged into the Workbench. If you're kind of like if you're someone who prefers working on the command line fully, there's also a terminal application that you can plug into here and look at. So for example, in the past in this workspace, I've done a genomics extract. So I did the thing that we just did now, build a cohort together, except I said, just please extract all the short read whole genome sequencing data for myself. So what you're seeing here is like a history of that genomics extract, when I did it, how big the size of that extract is, how long it took. And basically that extract gets put into this workspace. There's a bucket associated with this workspace, so that's where all the VCF files are living. And if I wanted to look at that, and then I could grab the path from there, and from my terminal, I'll be able to sort of list out all the information that's there for the VCFs. It's kind of a long list because it was a gigantic cohort, so yeah. So these are, so as a part of my genomics extract, this is all sort of the package of information that comes. And then I feel like this is where your journey starts forking significantly depending on what you're trying to do. I wanted to show one other thing. So this is, we're looking at all this in a sort of my production environment. Then there is a sort of pre-production environment where things brew up before they roll into production. So I wanted to show you 2 features that are in the works that are not yet in production, but we could look at very quickly together. I'm out of free credits here, but it's all good because I won't need it. Okay, so I mostly just wanted to showcase this right-hand sidebar. Crumble, which is already in production as well, it's essentially an interface where you can take a WDL pipeline and run a batch analysis, all via command line here. That's the way it works. It's a little bit, if you're familiar with the Terra interface, it is different here. So I think all this happens through the command line in terms of dispatching workflows. You can set up your own Nextflow environment if you're interested in doing that on the Workbench as well. There are tutorials for that. You can set up your own dsub environment if you're sort of like, if you're deep in the weeds using Google products. Dsub is sort of another command line option for running batch pipelines. So RStudio is sort of loaded here in pre-prod. The experience to turn it on and connect your cohort to it are near identical, so not super different. And the other application that's coming out soon is SAS. So depending on the different tools you've been trained in, maybe that's going to be one that you sort of are interested in trying out. We've observed that a lot of sort of clinical epidemiologists are trained in SAS, so they're very excited to test out this specific application on the Workbench. The other thing I wanted to show here is there's a feature coming out which is being able to subset your cohort by variance. So it's not available on production yet, so I'll show you very quickly. So as a criteria, what I can do is now I have an additional one called SNP indel variance as a part of my cohort criteria. So I'm going to go ahead and click it in. So it's not as simple as saying like, well, show me all, just select all the pathogenic variants here from this list of all possible BRCA1 variants, but you can sort of select into the exact variants that you're interested in studying. Lee. That feature is being discussed. I really hope it's coming because I feel like I think this is a very like brute force approach to having people select their variants because obviously there's 52,000 pages that no one is going to navigate. So that doesn't work. But I think this is sort of more of like this is symbolic in the sense this is step 1 in the direction of letting you basically curate your cohorts based on variant information. So it's not quite useful in its state, but this is probably the one thing that I think is going to be most impactful in 2024. That's my opinion, not the program's opinion, just to be very clear. Great. Any questions on any of this so far? And maybe the only other thing I would highlight in terms of the genomics front, since we're on this page, is that in 2025, we'll expect a release of also some RNA sequencing and proteomics data. So that's a little further away, but I think depending on the different scientific questions you're asking, that could be of interest for some of you. Anything else worth calling out in terms of like the 2025 trajectory that you think is worth knowing? Okay, no dates, no promises.
2025, like lots more samples, new data types. 2024 will also be more samples coming kind of later in the year. And admixture estimation, which I think it was all in your slide.
Oh, yeah.
Pharmacogenomics, star allele calling, and I forget the third one, I'm sorry. But yeah, and then obviously all of these sets will be updated for the new cohort.
That was a full demo. Oh my God, I hope I didn't exit.
Great, thank you so much, Ruchi. This was a really engaging exploration of the tool, which hopefully I think will make it a lot more accessible because I think everyone in the room has something that we could learn from this amazing cohort. And so we'll have another session next week that will explore some use cases where groups have gone ahead and use these interfaces and the associated data to kind of advance their science. So thank you again for a lovely presentation. And everyone go ahead and grab some coffee and second breakfast, and we'll have the main MPG start at 9:30. Thanks.
Thank you so much.